going to discuss longest palindromic substring question, and I'll try to wrap it up really quickly. I'll try to show you the approach and the question within 5 minutes. So let's get started. So this question comes under dynamic programming, and I'll tell you how we can use dynamic programming to solve this. But before everything, let's first discuss what is a palindrome, because that's what we want at the end of the day. So palindrome is basically a string which is same if you even reverse the string. Basically, let's suppose there is a string something like this. This is a palindrome. Why? Because even if you reverse this number or this string, it will be the same as the original one. So this is palindrome. So now our question is to find the longest of this of such string in this particular input that is given to us. Fine. So one approach for, before starting the brute force approach or before discussing on this, let's first discuss how do we calculate the palindrome. So we saw that, okay, let's suppose there is a word, the same word, let's take this word, okay. So one way to calculate the palindromic, whether this string is a palindrome or not, one way is to reverse the string and then check whether this is equal to the original one or not. So that is one approach. But reversing a string and then comparing it is not a good solution, okay. So what other approach is coming to our mind? How about we use a two-pointer method? Okay. So what does two-pointer mean? That is, we will have a left and we will have a right pointer at the start and the end, and we will keep on coming closer and closer each time once we are sure that, okay, both of these values are equal, right? Both of these values are equal. We can increment our left and we can decrement our end, and then we can check whether these two values are equal or not, and if they are equal, we can keep on going till the very end or till the middle. And once we are able to reach to a condition where our end is actually less than the start, this is the point when we know that we have covered the entire string and the entire string was a palindrome, and we can say that this is a palindrome. So how about we do something similar over on this string as well? We can take one value at a time, okay, and we can have one more for loop that could be that could be an inner loop which will decide our end. So we will have a start and we will have an end, and we will continuously keep on checking when they are meeting and when this string is a palindrome. If it is a palindrome, we will compare if this palindromic length is the max length. If it is, then we will update it, else we will keep on going again and again. So this is very brute force approach, right? We are looping twice to get the start and end bracket. That itself will lead to n square, and then we are again using n time complexity to check whether it's a palindrome or not, correct? The two left and right pointer that we are using. So overall, this brute force approach will cost us n cube, n to the power 3, which is not a good solution, right? What else we can do? Then there comes the dynamic programming approach. So what we are going to do, we are going to take one value and we are going to check that from this value, if we consider this as a middle value, and if we keep on going to the left and the right hand direction, and if we check whether the left and the rightmost value of this middle value are equal, then we will continuously expand our start and end, and so on, and there will be a point when this condition is not true, or when this condition is not true. At that case, we will run out of our while loop and we will return a result. So this is the approach that we can follow. So you might ask that why we are considering it inside as one of the DP solutions. So as you know, we are using the past value, that is our b, to calculate whether this entire string will be a palindrome or not. Let's talk about, let's suppose we took this and we keep on expanding that whether these two values are equal or not, right? So we checked, yeah, these two values are also equal. That means, yes, this is a palindrome, right? and we will even expand our start to furthermore, and we will expand our end, but this condition is not true, so we'll come out of our result and return the result, right? So in this condition, what we are doing, we are taking help of the previous value to calculate the current palindrome, right? That's what dynamic programming is about. We somehow figure out how we can use the old data that we calculated to calculate the newer data. So that's why it's under dynamic programming. So enough said, we have discussed about the time complexity as well. As I mentioned, that we will be taking one value at a time, that will be of n, and then we will be calculating whether it is in a palindrome or not, and we'll keep on expanding it till the end, or till the time both of the end values are not equal. That will be again n time complexity, so n into n will be n square. So that's the approach. Let's quickly go into the solution. So for solution, I'm just checking some random conditions, that if our size is 1, then there is no need to check, just return s, because this value itself is a palindrome, this value itself is a palindrome, right? So in those conditions, we'll directly return this. And then starts our actual process, where for each string we will be calling a helper function, which will just check whether the middle value or the start and the end value, initially that both the values are equal. And every time this condition is true, we will keep on expanding our start and end. We will decrease our start and increase our end, and so on. And every time we will check whether the space between them is more than max. If it is, then update your max and update the result and return the result. And that's what we are doing at the end of the day. We are adding one more additional condition, or we are calling this helper condition one more time, that is for I and I plus 1. So you might ask why we are doing this. So let me show you. This is a good example of this, right? Let me curate this in a better way. We know that CBBC is a is the longest palindromic substring over here, right? But it's an even length number, right? So for this, what we are doing, we are checking I and I plus 1 both, and accordingly, if both of them are equal, we are decreasing a start and increasing our end, and so on, so that this will also give us a palindromic substring at the end of the day, and we will return it. So that's about it. Thank you so much.